Okay, should be back live here. Hello. 11:30. A little tidbit late today. A lot of exercise in the morning. But I've had some good time to think and it's kept my head very clear. I know exactly what we're going to do today. Spencer's been working on this HL Gauss implementation. Let's actually see. Let's do it this way to be sure. Yeah, this is better than before. This is slightly better than before. So he's got this HL Gauss implementation that's like, well, it's hard to really say with any real significance, but it's at least as good as before. Um, and what we're going to do is, because HL Gauss is also one of the main annoying to implement components that really matters for off policy, we're going to see what happens when we use this with off policy methods. Now, the thing I don't know about, see how he has this implemented. Okay, so it's the same value function as before, right? A singular output. Singular output, right? How do you handle continuous actions with well, do we just do it for discrete first? I think that's what we do, right? Honestly, we can kind of just repurpose the decoder, no? And we just train it a bit differently. Decoder's going to represent something else. Okay, so we have logits. Then we do off. And we have to sample from logit's epsilon gradient now, right? Something like this, right? This should be your off-pol sample, I believe. See if this works. Enter's not. Wants me to do this. Okay. Well, that seems weird. Okay, I see some trues in there. Hello, welcome. Which RL objective are you implementing? I'm trying to make an off-policy version of PufferLib. So the basic thing is just getting two functions of some type into the trainer. We have HL Gauss implementation, which, from my research, it seems like this is the most crucial trick to have in place. And we actually already kind of have a lot of the other ones that are required for off-policy to work. So pretty much the goal is to see if we can get some sort of off-policy objective that matches the performance of our on-policy implementation. It's probably going to end up looking something like Rainbow, but with better distributional and without a couple of the tricks that don't actually seem to make a difference. Oh, so it shouldn't be log prob, it should be logits. And I guess it's all the same initial state, so it's all going to be the same action. That's fine. Okay, but this gets us our action, right? And that should be all we have to store for this. There's HL Gauss in here. Yeah, we have HL Gauss here. New value logits. Ah. New value logits. Did he actually modify this? Kinda did. HL. Okay, so he actually did do this. Hello, Kyoko. Are you done with imitation learning? No. What this is I would call this somewhat of a continuation. So we're doing off-policy work now. The thing that I think is important from the imitation learning, right, is that there is a... it is possible to write a algorithm that behaves very qualitatively differently and in places much, much better than our current state-of-the-art on-policy implementation. So, and it does that by reusing the highest quality old data, right? So this is why I'm now playing around with off-policy, because given that, we should be able to come up with an off-policy algorithm that is very close to our on-policy algorithm, but lets us actually use an experience buffer. That is going to be the objective. And the result of this is that the hard exploration tasks like Neural MMO3, we should see progress happen very quickly there, because when you get a few good samples, it will actually keep learning on those. The cool thing is PufferLib's kind of already set up such that we have a lot of the tricks that are used in off-policy learning already in an on-policy setting, so it shouldn't be a huge modification. The main thing that's confusing is like how we're going to change up advantage function and such with discretized Q function that has HL Gauss in the mix. Welcome something. I do think that it should be possible to make something like this work. I don't know how close it's going to be to existing off-policy methods. Any guideline you're following? Well, I've been reading a ton of papers lately, and so at this point I'm trusting. I'll reference some papers, but I'm mostly trusting my own best judgment. Play buffers and puffer. Here's the thing, Anshul. I implemented them in an early version of 3.0. They didn't work because of the because puffer's on policy. I tried to do exactly this, and it didn't work at all. So now we're going to try to actually go to off policy and see if we can get it to work with this. Value logits. Value. Okay, so there actually is... Yeah, the value function actually works here, doesn't it? Logits, value. Well, don't go getting excited to try a thing yet when it's not... I mean, research is like the most fiddly bits you can possibly have to deal with, right? Actually, let's just make this new value log probs. Or it's an observation, how to help. Yeah, it stores past data. So the idea is you should be able to reuse past data in learning. Way to do this. Guess we just replace the I guess right here, right? We have damn function. squared error, right, on what did they define yi as. Yeah, so it's r plus q of next state So I should actually be able to just do, since I have this over segments, right? And this is done the tricky bit and how to reformulate things. What is the yi? Oh, yi is new to RL and tried Tetris with Gymnasium plus PufferLib for PPO. Did you try R Tetris? We actually have a version of Tetris that's very fast. This is the policy that it just trains out of the box on it. PufferLib for games only? Nope, not at all. Here's a driving env. We have a driving env with real-world map data. Here we have a drone flying environment. There are all sorts of synthetic tasks as well, not for games only. Games are just really, really good for research because they're very interpretable. So naturally, a lot of research environments that we use for improving our core algorithms and evaluating methods are going to be games. They're frankly much better than controlled tasks for core research. Gamma. Where can I find code example for Tetris and in Ocean? It's in Ocean. Like, if you check the docs, right, we have walkthroughs on how to build environments, and, like, all of our custom M's are just in, like, PufferLib Ocean, and there's a folder for each one. The code is, the actual core source is one file for each environment. There are, like, some bindings to Python and stuff, but all the logic is just in the .h. I can promise you that our version of the Tetris is going to train at least 100 times faster than whatever you've been messing around with in Gymnasium. At least on decent hardware. Puffer very fast. Sure thing. Okay, that's totally the wrong scale. Oh, because this ended up having an extra dimension somehow. We just do... Okay, so this is correct for actions. I don't like that it's all the same. Um... Oh, because it's stupid, of course. Yeah, hang on. Bob. No, we can't do choice. We're gonna do this super hacky at the start, right? This is not fast code. Okay, this is better. 5% random choice. Epsilon greedy. Ah. Wait, hang on. It's queue of actions. Um, we'd need to view... Is this correct place? What do you mean, Rishi? If you're trying to post links, YouTube will stop you from doing that. It's in PufferLib/Ocean. Yeah, that's not right. No, not at all. Nope. The reward, it's reward plus. I think that it's the current reward. I think it's this way. And this should be QA. Okay. That is a correct loss. Or at least it's a loss that doesn't break. Interesting. Hmm. Well, I mean, this is our initial. Oh, I don't think it's saving. This is our initial implementation. Oh, Nan's out. I see. Cool. Well, this is our basic queue function, right? Do I spend time now? Do I spend time trying to get this to learn? be able to do it on break, right? If anything, rather. I just wanted to get something above the noob reward, which is right there. Let me make sure I've done this correctly. Oh, that's probably way too high epsilon greedy, isn't it? Hmm. Well, the policy full determinizes there, doesn't it? Hard to say. See? Dang. Not very familiar with PufferLib since it's designed for typical RL agents to have plans for RL with LLMs. No, we do everything except LLMs. It's the typical RL agents, but everything that we have is at least 100 times faster. Sometimes 1,000 times faster. Very, very high performance training of small models. Where the heck did they put their hypers? I have a table. Okay, so it's actually pretty high. I wouldn't have expected that. Amusing. Hmm. But we're probably still just looking at noise. Hey, Georgie. What's the strategy here? SAC. Nah, SAC is super freaking slow. And I honestly haven't seen good compare. Like, SAC doesn't even compare favorably. The goal is to get Q functions of some variety into an algorithm that is as close as possible to our current one. Basically, we want to do exactly what we're doing now, but we want to do it off policy so that we can actually have a replay buffer. You published some paper? Yes, I did. It will be on archive shortly, but we won an award for it. Dang thing. Why does it not show my freaking posts? What? It literally doesn't show my posts. You're signed out. Hang on. Let me go get a separate window on my personal. Okay, there we go. So, my whole talk is right here. This is the talk that I gave on, it's like a 7-minute talk at RLC. And I put a version of it here on X. It's also on YouTube. Oh, is it already live? This is RLJ. So I guess it's on here, actually. But I archived it yesterday. And I don't think it's live on archive yet. So it's already here, but should be live on archive soon. AFBRR, we're doing off-pol work, or attempting to. The problem with off-pol methods is, like, they really don't work until you add a whole bunch of tricks. So it's actually hard to know if I've made a mistake or not until we have a bunch of tricks on it. Let me take one more look at the function, the loss function. Oh, hang on. No, because this is done implicitly, right? The discounting is done implicitly. RT, yeah. So, the loss is just they define yi. This is going to be r plus gamma max q. I believe I have the correct reward, right? Because it's observation, and then the reward, observation action, then you get the reward. Yeah, I think that the way I have my buffer set up, this is correct. Drive with a bunch of papers. Yeah, you can do that. Max. Yes, you take maximum Q, and you shift over by 1. And then you take Q of the current action. So unless I've messed up my tensor indexing somewhere, this should be correct. Yeah, this should be correct. Okay, so then why does this not work? Hyperparameters, tensor indexing problems, or base DQN just being like horrible bad. Because I think that's all I'm doing, right? Is I've just basically hacked DQN into this, which obviously is not going to do very much. Oh, and then wait, you do take the action that was previously taken, yes? No, this is fine. Okay, so things that I'm going to have to add to this, right? I'm going to need to have the multi-step bootstrap, obviously. Then missing the advantage estimation is the real big one. Obviously, the HL Gauss is the other really big one here. I should be able to get this to learn something, though, I think. Let me see if I can play with this a little bit. Actually, let's go check CleanRL's implementation. And I start with this. They should have, a super basic. Yeah, gotta love Costa. 200 line. 100 line DQN. Exploration fraction. Ending epsilon. They actually do kind of anneal it, don't they? Yeah, they do kind of anneal it. Use target networks too. Oh yeah, what did I miss? I probably missed something completely there, didn't I? I haven't done, I mean, I'll see it in a second. Hang on, let me at least get epsilon to be reasonable. This has to be annealed, so it would probably be something like... Two times, no way, not minus 2 times the minus 2. I think this is right. Yeah, so after half the steps, roughly. Loads, double Q. You don't need double Q it. Like, the initial one doesn't have double Q. And double Q doesn't do anything on Rainbow and, like, the more advanced methods. I don't think we need to care too much about that. Does the original DQN have a separate target network? I didn't think it did. Because, like, the double... You don't need double Q. If you look at Rainbow and, like, all the different tricks and the ablations, like, the double Q doesn't actually do anything. So that's one that we don't need. And it's expensive as well. Okay, now let's look at CleanRL's implementation. This, we don't need any of this. Oh wait, they do have a separate. They have a separate target already in the initial DQN. Interesting. They're fully separate as well. I forgot that like the original. I didn't think there was a separate target network in the original, but I guess not. I guess there is. Oh yeah, we're also then. Yeah, I think that we just like go off of this and we try to match this as close as possible, and then we start adding all of our stuff back in. Yeah, kind of modify in place. But off policy. Yeah, weren't you were implementing some stuff, right? What did you post? You have this not in PufferLib though, right? You have like a standalone thing, don't you? HL gas help at all. That's what we're gonna do right now, Spencer. So I'm getting like a basic DQN into Puffer with like reasonable perf at first. And like we're gonna need HL Gauss for it to work at all. This I open this thing. Of course it opens VS Code. Okay, you did kind of take our buffer and structure, I see. Okay, thank you. So I will put this on my other screen then as a additional reference for this. Did you do experiments like to see what mattered? Because like I was looking through, I basically went and I cross-checked a bunch of off-policy papers, and it seems like the most important stuff, right, is having some sort of prioritized replay, and then having well that's second actually. The most important thing is having uh some sort of distributional objective so you're not doing quadratic loss. And then like prioritized replay and a few other things. Multi-step bootstrapping. I have this now on my other monitor, so we're gonna cross-reference both. I gotta get the basic thing into proper puffer first. Oh shoot, yeah, we can't even do it. Wait, we can't even do it fully unshared, right? Does anybody know if you use a shared backbone for Q and target, does it totally screw everything up? Or are you kind of okay? Can I just do self.q target? Not I, well, it might be similar. Can I just do this? Should be a copy. Yeah, but A1, the way that Puffer is set up, there's an LSTM in the backbone. So like you're not gonna we'd have to do like two separate LSTMs. I'm gonna just share I'm gonna share the main net and just have two separate output heads for starters, and we'll see if that breaks everything. Get out of here, bot. Really trying to bot on an RL string. Alright, so I think what we do is we just like start cutting crap. Q. Then let me see how clean RL does it. Super. This is like a really good read. Way easier to follow. Wait, does this not get the action from? Oh, here you go. Yeah, so this is the actions come from the Q network. This is just going to be Q. So is this not considered the double DQN? Or is this not considered double DQN? That's something different. I didn't look into the details. It's been like several years since I've looked at that. I didn't look into the details because I just saw that in the more recent methods having double doesn't actually buy you much. I kind of just ignored it. Have Q. This comes out correctly. This crap. Minimum of 2 values. So separate from having Q and target, right? This would introduce a third one. Have you tried Muon for RL training? Yes, we use Muon in all of our baselines. It is much better. This was one of the main additions to Puffer 3.0. Okay, so that's probably the idea is that you take the min in order to counteract the bias from having a max in training or something like that. Yeah, that's a silly hack. It doesn't actually do much, it looks like, in the well, the better methods. The problem with DQN as a starting point is it's just such a crappy method that like literally anything that you do will improve over DQN. That perform better than Atom W in your test. Performs better than Atom. You don't use Atom W in RL because weight decay is pretty rare. You don't really ever use weight decay in RL. I mean, you're free to try it. I have never gotten anything out of it though. Yeah, it's a big difference. I mean, I would just check out PufferLib, right? Like we have all of the we have all these advancements just there for you by default, and there's blog post coverage of everything that we've done, and it's going to be much faster than just about every other library. Not just about every other library, faster than every other library, really. Better in general. But like from what? They should kind of be the same thing, right? Like think about this for 2 seconds. You train a policy, okay, with a value function, or you just train an action condition value function. These should be like the same thing, and it's probably the surrounding details that are making any differences. You can't just have on policy being strictly better because like throwing away all of the old data, um, it means like you can't even keep around high value data. Like let's say you even have expert data in there, you can't use it. It's a big problem. Do this, and then where is the train step? How to train. Also, why would it make a difference? Like how to train Atari games versus whatever else? It literally shouldn't make a difference. Or to train a value function. Much harder to train a value function. How to do a control loop. But you train an action condition value function should be the same thing. Like training a value function, it's the same thing, except that the value function has to guess one additional action from the policy. Okay, so I'm a beginner in PyTorch. I can write some custom models. Where I can write advanced level. Will issue what further read. Follow my basic programming and ML guide on X. It'll direct you to CS231N. Just do everything in CS231N and you'll be good. Sampling is different. You don't sample entire episode. What do you mean? What do you mean you don't sample an entire episode? It's like you totally can, right? There's no reason you can't. Like the point that I'm making here and why I'm doing this, right? This is not like basic, like oh, implement like simple, simple off-pol algorithm. The key that I'm trying to get at here is that these methods really aren't that different, except that if you apply them correctly, having a Q function should let you reuse old data. So ignore all the surrounding details of how these algorithms are typically used. That should be an advantage, right? So it's possible that like you have that and then everything else is a mess, or like pieces of what is typically put around that is a mess. But I want that core piece of being able to reuse old data. Running some training results for stats that you want to see. I'm using 1B. Just want some training curves, FBRR. Want some training curves on like reasonable problem and then link like an image or a video of policy doing reasonable stuff. I will try to make some time for you tomorrow tomorrow or Friday if you're around to go through and take a look at that PR. I want to do off pol today because I have it fresh in my mind. I've been reading a bunch of papers. Okay, so now we do. This comes from the target, right? Wait, what the heck? Target. Oh, okay, I see. Yeah, this is fine. You did actually double check the math, right? Like you have the math either from your background or from stuff you studied. It's not just from Claude, right? Because that's the key thing. Okay, so this gives us target net. Now we have to construct. Wait, no, this is QA. And this gives us the action net, right? And then we have the target net has to be. Yeah, the target's going to be different. So we do target max. Words. Something like this. Do. This is your target. times 1 minus done. Hey Joseph, if you have time, please consider making an intro to RL with PyTorch. So, I have literally a full guide for you. It's not in video form. Video form alone is a very, very bad way to learn. You cannot learn this stuff just by watching videos. The thing that I would suggest, and this is a complete reference guide, if you follow this, you will understand RL. You'll be able to contribute to research. You'll be able to help advance state of the art, and you'll be able to do a bunch of stuff. It's on X. It's on my articles tab here. It's supposed to be on the website. I think I never finished reformatting everything nicely on the website. So you'll want to go here. And this is my guide to RL. And if this is too advanced, go back to my programming and ML guide. But this will take you through the process of building environments. This will slowly introduce you to background papers. This is how you learn RL. This is how you do that. Because this is the most common question I get, so I made one, right? And pretty much the best contributors in PufferLib got good by doing exactly that. So it's a lot of work. It's nowhere near as much work as I had to put in without having access to that, like those resources and PufferLib and everything. It's still a fair bit of work. It's a matter of if you go through all of it properly. Pretty much it. Okay, so we have to do paid Sims and Raylib for like the last few years. Oh, awesome. Raylib's the reason I found Puffer. RL. Gordon RL. Okay, cool. Ask him. Okay, good. So you actually have background. Very, very good. I have to ask, man, because when people submit me big PRs, occasionally people do just like LLM slop a bunch of stuff without having, actually put in the effort to understand things, and it's a big waste of time. So as long as like this is not that, like, yeah, that's awesome. Perfect. Then yeah, if you've written Sims in Raylib, then of course it makes sense that you were able to do a somewhat larger project like this. Very nice. So yeah, let me know, and let me know when that is in. I'm not going to review it today because I want to do this off-pal stuff for a bit, but I will do it this week for you. And that's like a pretty exciting thing if you can get that to work. Like I sent Finn and Sam, who did the drone environment. I sent them a drone to play with. I'd be willing to, like, if this is good, I'd be willing to send you like a simple robotic arm to see if you can get it on the real hardware. And yeah, there's a lot of stuff you can do from here. Depends how far you want to take it. But it is one of the most obvious applications of PufferLib to industry. So there's a lot of opportunity. I see. implement the RL side. Oh, I didn't see that last comment. What do you mean ways to implement the RL side? Like, that is what PufferLib does, right? No idea what it was. Now I have a pretty good understanding. So, the one thing that roboticists do really weird is they use state-based continuous rewards. So they'll do stuff like the closer you get to the target, the reward goes up, and then it's 1 when you're at the target. Do not do that. It requires a very sketchy RL implementation and will break. Basically, it's 2 errors that they make. They make 2 errors, and that they cancel each other out. So what you should do is you do delta to target. So like, let's say that you want to get a reward of 1 for going to the target or whatever from infinity or something. Then you define the reward as you get reward for getting closer to the target, you get negative reward for going away, and then they add up to 1, right? You do something like that instead. Something like change in distance to target divided by some normalization factor, for instance, is a linear one, is very good. So that's the main thing that you're not going to be able to look up in a book somewhere. You can check the drone environment for an example if you want on that, because I did that there. Okay, let's see how this is. Yeah, this gives us a proper loss. Same thing as before, but with a proper loss function. Let's make this actually tray and fix anything broken. Okay. Runs. I have it set so gains reward based on percent change. Percent change. Make sure that it can't jitter and get reward. So make sure that if it moves like farther away and moves closer, or moves like closer and farther away, make sure it sums to 0. Like there's a common hack, for instance, where if you see it just hovering around the goal, for instance, it's usually that. You've messed something up with that. Why does this thing do loss? Okay. Wait, hang on. Data. Yeah, this is the target gets next observations, right? And then the Q network gets observations. It's rewards. This is a pretty simple simple setup. Okay, so what do I have something wrong, or is it just like fiddly? You run Q and target on the mini batch of obs, right? QA is going to be Q function of the current action, or rather the Q function of the current state with the selected actions. And then we get target, which is going to be the maximum terminals. All right, and then we get an error between, this is going to be, you overlap them, right? So this is the first one, and then it goes forward. Log QA and target, maybe? I was stuck with that earlier because I had, hang on. Oh, they nan out, lovely. I convert. Stuck with that earlier because it had a reward for moving closer than moving away, so it just jittered. Yeah, exactly. That's like a very common bug. And it's exactly what I just described to you. Dang. Is the shared target really messing us up this bad? Or is it something else, right? It seems very unstable. What we're doing makes sense, right? Even though we're using like on-policy data with off-policy learning, but it's still like a ton of data. Do I want to do like the same sort of advantage estimate? I The thing is, it's like it's tough to know whether I have something wrong or whether like yeah, base DQN's just a sucky algorithm. So obviously whatever configuration I have by default on my much more stable, much better algorithm is not going to work out of the box on the much fiddlier, like worse algorithm. The target network should get the next states, not the curve. Doesn't it do this? Because look, I take right here. This is next state, isn't it? Like I shift it by 1. Like I suppose I can try it without the LSTM, but then it's much harder. Yeah, I shifted logics and targets exactly. There's still this shared backbone thing, which is probably iffy. But I don't know I really want to remove the LSTM either. I just want to see this do something better than, like 6 or 7 score for reference is, it's like the trivial one. Even if I got like 10, I'd be happy, like, oh, okay, this learned something. But yeah, getting up to like 6 point something, that's like the sort of the trivial one. I think you can even do that just by going to one side. Like the side that the ball usually falls to. Or whatever. I miss any other like important details? I don't think so. It's a very basic algorithm, right? They have this silly copy thing. It seems like a bad idea to like move on to the optimizations of this if I don't have this doing anything. Can I try it on like Cartpole? Let me just try it on an easier task. To I have some numbers hard coded. Change this. 12. Action. MB obs? What do you mean an MB obs? Yeah, so this definitely doesn't work if it doesn't solve cart pull. We'll use this as our testing task. Let me make sure I don't have this backwards. Yeah, this is eps prob, eps choice, not eps prob. I think this is good. Does cart pull even have an LSTM on it? Oh, it does. Alright, let's mess with the frickin' target networks. Claude is not going to do anything but waste my bloody time. Okay, I think we can hack this as just like... You. Target is the same thing. What's this, this thing here, right? They like sync it. Wait, args.tau. What is this tau param? What the heck is this? This weird lerp thing? Target network update rate 1.0. Okay, so it's 1 anyways. Okay, so you do something like this, yeah? And then... Okay. We have this. Now we need the target network update. Probably like here-ish, yeah? And then the other thing is there's a stop grad on one of these, isn't there? There is a stop grad here, right? Target network. Q network. Wait, do you train both of these? This doesn't make sense, right? I'm pretty sure you don't just train both of these. Oh, wait, is the optimizer... Hang on, hang on. The optimizer only is... Yeah, the optimizer is only on the Q network. So the target we detach. This. Still no, huh? It's kind of being weird now. Update and slowly update the target weights. So are they not supposed to be synchronized as often as possible? Target network frequency. Oh, 500. Holy. Okay. We update the target more slowly, huh? Oh. Well, this is... They should be close. Why wouldn't you just update them all the time, then? They're not going to be close if they're 500 updates stale. Oh, there we go. Okay, look, that actually did something. If we train Cartpole for a frickin' billion steps, does this do it for us? All I need is to see something that's actually directionally correct. For me to start messing with more things. Of course, now the problem is that it's going to take forever on, like, collecting random data. Maybe not horrible for Cartpole, we'll see. Okay, so now it should be pretty much just collecting fresh data. And now it starts flipping around a bunch. This didn't work. Should need a billion steps for Cartpole anyways, even with, like, a bad algorithm. See if this reproduces. No, see, now it's not there. Same thing as before. Uh... Yeah. Hmm. Just lucky a few episodes? It doesn't seem like it could be. That's, like, too much to just be lucky, right? Look at the details of this thing. We have fully unshared nets now, right? And this seems like roughly... This seems like it's the correct algorithm to me. The learning rate's freaking massive. We mess with this. Doesn't help. Do one more order of magnitude just to be sure it's not this. This is the easiest problem ever to learn. For reference, you literally can learn this without reinforcement learning. You can literally learn this just by doing imitation learning on, like, best experience collected. I did this yesterday, and it solves instantly. Oh, wait, hang on. Hang on. Stupid. This has got to be target. We're still using the same network, right? This is QA, the target. Find the bug and it still doesn't work. Try this again. Nope, not any better. Maybe are we doing this correct? Zero. And wait, what? Where's this come from? Hang on. 0, 1, 0, right? Where does a... Oh, okay. Yeah, well, this is completely wrong. Cool, it's an indexing bug. Now this is what I can double check frickin' LM for. Because this is a basic doc lookup. Okay, it's A range and then I. I. Oh, 6-8, right? The 1-1-0 should be this, this, this. We get this, this. Yes, so that's correct now. Boom. Learns. Indexing bugs are lovely. Now, is it super stable? Is it good? Those are completely different questions. But does it learn? Absolutely. I just dropped the learning rate a bunch. Yeah, that actually learns, funny, it learns faster than our, fancy algorithm, which is, to be fair, not optimized at all for that. But yeah, there we go. You go back to breakout. Still Gauss. 5. I forget, maybe it does, but I thought it took a little longer. Whatever. This is gonna be... Welcome, Spencer. This is our first off-policy thing that we've done in Puffer. Interesting, doesn't do anything on breakout. Like, at all. I think we can keep cart pull for now. It's just an easier task. And like the current implementation just sucks, so kind of to be expected. But we can actually use this enough to like add all the extras into this and then optimize. Oh yeah, you're right. I made it way more steps. You're totally right. I forgot that I'd made it 200 million steps for frickin' cart pole. But that is our first off policy result in PufferLib. So I'm gonna make a yeah, I 10x'd it. You're right. I'd forgotten that I'd 10x'd it. It doesn't matter though. Like we're not expecting this to be good for starters. We're just expecting it to do something, right? Five. And now what we get to do, we get to add in HL Gauss as like the first big trick, I think. Do you actually know how to do it? It's a little harder because I think we have to do. Well, I might be able to reuse your same code just slightly differently. Is this the research? Is this the research easier than env side? Not exactly. So the difference, Spencer, and this is generally true. The difference is that based on the current capabilities, when you're building an env, you roughly know what the correct end result is, right? So like if the thing doesn't run fast, you know that you just have it slow and you can profile. If the thing doesn't learn, you know that puffer is good and you should be able to at least train something. The problem with the research side is you literally don't know that, like, you don't know what target you're trying to even hit, right? And the only thing that you can do to build up a good estimate of what target you're trying to hit is to get really, really good at cross-referencing tons of papers and like fitting a mental model of like basically a probabilistic model of what is very high likelihood to work if you do it correctly, what is less certain, and then like an estimate of are you doing it correct slash does it just not work, etc., etc. So the research side is hard due to uncertainty more than anything. It's very, very uncertain. Like especially the stuff yesterday that I was doing, like I have absolutely no idea what the ceiling is for that type of work. Like if I just did the best possible version of that, how good could it do? Nobody in the world knows. That's what's hard. All right, I will be right back. I'm gonna use a restroom, and then we are going to we're going to add your HL Gauss. And it's a little different, Spencer, because we're not adding it on a value function. We're adding it on a Q function, right? So then this is actually going to go directly into the... well, this will go directly to swapping the objective so that the main training objective is not quadratic. It's not a quadratic loss, squared error. It is a classification. Q function to bins. Yep, exactly. I don't know if we need to do the whole Q function, actually. If you want to think about that for a second, while I take a minute, um, I think I only need to add HL Gauss to the action that was actually selected. I'm pretty sure. I'm not positive, though. What are we researching today? What's off policy? Off policy means Q function related stuff. I'll be right back, Andrew. One sec. Client stuff. Yeah, do the client stuff first. I will do, I'll handle research for a little bit. All right, so we have basic Q learning. Next, HL Gauss. Where did HL Gauss? You just bin both of these. Hang on, let me think. It's slightly different from normal because you have two targets, right? Look up the distributional mathy. I just need to figure out from this how they quantize. I in a discrete distribution, home of fixed location. Followed by KL minimization. Oh, so they do this for the... So it's not cross entropy, it's KL. Right? Okay, so I see. So what we were doing is we were turning it into classification before, right? We were turning the value function estimation problem into a classification problem by binning the value function into a number of discrete quanta, quantizing the value function, the simple way of saying that. And that lets you do a classification loss, right? But because you have two different things to discretize here, you have the Q function and the target, you get two different distributions, and then the natural optimization metric is a KL distribution, or is a KL divergence term, rather, which is still a much better, like numerically is still a much better optimization target than the squared error. It's a much more expressive loss function. Okay, so like, why is this even in the policy? So Spencer messed with the policy to make this work, right? Spencer. Spencer took the normal value function right here, HL Gauss. Input Vmin, Vmax, number of bins. Is this one good? Target probs. I think this is fine, isn't it? Yeah. I think we can literally just call this. We can just call this on both of them, can't we? Like, if I just take this, okay, paste this down somewhere, grab this signature. I think you don't need to even make any modification at all. I think you just go up to... You go up to your Q functions. Anyone can correct me if they have knowledge to the contrary. But I'm pretty sure we just go up to our Q function. So here's the action condition one, right? And here's the target. Okay. And then we can do QA.view -1, like this. QA want Gauss target quantized. Then we do Q loss. Is there a KL loss in here? It's really basic, right? Yeah, it's just this. Y true times log Y true. Torch KL loss. Manually did the KL in my version. Yeah. I don't know if what I just did makes any sense. We shall see. I think it does. Oop. 150 happened. Size of tensor must match. What is this thing supposed to take? Input. Bmin. Bmax. Is this thing not supposed to be a flat tensor? This thing's supposed to be something else? See how I can figure this out. Probably dist. Zero dist. Oh, is it, you do not just call this? I thought you just call this one on the other, no? You did it different. We have this code down here. This is the same code, isn't it? Maybe there's not supposed to be an unsqueeze. Ooh. Heck, why is this not valid? Oh, of star 9. Yeah, this is wrong. Okay. Well, this still works, right? It seems less stable. Yes, way less stable, no? Way less stable. Oh, well, because, yeah, the Q function blows up, right? This one doesn't work, though. Is there something that's done to normalize this so it doesn't blow up horribly? Maybe, let's see if Costa has an implementation. Honestly, the CleanRL implementations are so much better than reading the original mess of papers. Like speedrunning, how can we confuse you with more math than is required? I guess C51 should have at least some reasonable form of this. How long is this? Oh, this is not bad. That's the idea. The idea is that binning is better than MSC, yes. And there's very, very extensive evidence for this. Like probably more than most of the other things in off policy. The hell decided to call this atoms? Okay, so this is what it is. It's just a lin space. They actually do negative 100 to 100, which for this they actually do that. And then wait, why did they actually output times num atoms? Kind of sketchy, isn't it? Yes, Spencer. I do notice though that they have the output here. The output of the Q function is actually equal to the number of actions times the number of atoms, which is not the way we have it implemented, right? They actually have this big blown up final layer. This is the C51 reference, which has distributional stuff in it. Work. Next, okay, this is atom bullshit thing. What is the soda LR sketch? And we use cosine in PufferLib. Most libraries have linear or just don't even have it. From my experiments, at least, the choice of scheduler matters a lot less than just having it. Like, you really need to have a scheduler. The choice of which one you use matters a lot less than just having one. And then also being able to tune it, obviously. Yeah, that's what we do at the moment. You could add additional hypers if you wanted to, like, mess with final learning rates and stuff, but we just decay to 0 at the moment. Doing that does slightly mess with your graphs a bit, because, like, it makes most things look like they're leveling out towards the end of training, even though it could just be the learning rate, but it's still pretty good. That's the only thing I don't really like about it. Well, they do have in here negative 100 to 100. Representing the even. And I don't see any sort of normalization on this. Yeah, this doesn't have enough resolution, right? Like this for now. Okay, so the really big thing is the bootstrap, right? And step bootstrap. I want to grab it from here. Right one. Wait, can we do JE with this still? Hang on. We do JE. There's no reason we can't just do JE, right? To make the targets. Or puffer advantage, rather. Here's multi-step learning, right? Okay. Let me see if this makes sense. What do you need for this? You need values. Yeah, we can totally do this, right? Let's just move this thing. Oh, well, we use it for sampling as well, don't we? Which is totally screwed up because... Yeah, this thing is totally screwed up. Because basically we should have... use this for sampling at all, huh? You can have it be stale. So super unstable, but there you go. Does learn. Go grab all this crap. Grab all this crap. Okay, so we do target. Use the Q value of the target function for advantage, or do you use the your own Q value? I don't know. Let's try this. Do Q sub A towards Q. Ratio. This let us do anything. Advantages. We can compute advantages. And do we use these? I think you do like this, right? MB returns is going to be advantages plus QA. Well, no, you would construct this from Q target, right? Because this is, yeah, this is the target. This is what you're doing instead of the target. Okay, so you do, this is going to be, this is going to be target, target.max, yada yada. You don't need to multiply. Okay, so now you have advantage computed by target. And then I believe that it's something like this, right? Hmm. This. Okay. Oh, okay. So something like this is actually reasonable, I think. Super unstable. And then The replay buffer, suppose. Structure of a replay buffer is trickier. We could just see if we can get this, something like this to work first. We're missing filtering as well. Yeah, we're missing filtering here, right? That's pretty major. But the idea here is that so the target is the value function, right? The target's the value function of taking it's an optimistic one. It's because it's under the best action. Then this should be advantages plus target, right? Advantages plus target. Will not work. This is actually not that far off, I'm pretty sure, right? So you need to save... We need to save the values. Yeah. Okay, so I think the thing that was wrong here, okay? Undo a little bit of this. It's pretty close. Okay. So this is where we're going to go back to. And we're going to store the targets where the value function would go. This is going to be target. Okay. And now, this is a slightly off policy advantage estimate. Okay, and we use this. We use this to select data. Just like we did before. And the only difference now... Well, actually... Try something. Let's do target equal MB. Try this. mess up somehow? Why does the target have this dimensionality? Right, you need the maximum of this, okay? Okay, so now we have our target as MB advantages, right? Now we are actually doing general advantage estimation on this. And, okay, this does do some learning. Now, the only thing that's wrong here, this value can get stale. So what we would like to do is we'd like to update... We would like to update the values, right? And we do this by rerunning... We have to rerun the target computation, don't we? Do you see the problem here, right? The problem is that this is the original value that gets stored. And this is going to be stale because we're going to have updated the policy. And we do not want this to be stale, otherwise we lose the generality of all policy training. So I think what we do for this is we grab this like compute puff advantage thing from down here. And we're going to do it right. Okay, we're going to do it right like this. We're going to grab this target computation. Value. This is going to be target max. And so we have this again. I think this is good. Now we take the advantage. Okay, so we have this. Where's this ratio thing? That's an important sample. Shoot. We have that. That's gonna have to change. We can make this ones for now. Okay, so okay. And now we just do here this target. Right? I think that something like this is correct. Because now make sure we get this right. Oh, this is advantage. Still no? Okay, so target is mess this up. MB values. Like this. Because it's the selected. Okay, so evidently I've broken something. I think I've broken something, right? What have I done wrong here? 1, advantages, zeros. Current is going to be values plus this. Now, this is normally what you would do, I think. What have I messed up? To your advantage, use this to sample data. And MB values. Get your maximum target. Okay, this is a solid estimate here. Do this on the current data. And then, wait, did I forget to shift them over by 1? Isn't it, this is like colon 1. There we are. Well, super unstable, but at least we get something. Super unstable. Yeah, because the target's blowing up. But does an algorithm of this form make sense, right? That's the main thing I want to figure out, which is you replace the policy and value function, the Q function, and the target. I'd like to understand why those need to be 2 separate networks, but sure for now. Disadvantage estimate still makes sense. Well, it's kind of weird, isn't it? Like, technically, yes, you can write it. I think that there is off-policyness thing again here. Okay, but like outside of that, this should be a very close to comparable algorithm, I would think, to what we had originally, provided I get it correct, right? Because like all I've done is I've replaced the policy and value objective. Oh, I suppose we also don't have entropy in here, which is a problem. Right? So we'll have to fix that. But like this should be a substantially similar algorithm to what we had before. And then the question is just like, okay, why doesn't it work as well? Be any number of things. Well, first of all, let's see if this, well, hang on. I think before I do this, I'd like to get this to be stable. If I just do the Q target without advantage, if I just comment this, does this do it? Oops. How'd this happen? Right, so this has got to be target equals this thing here, right? Here's previous version. This is supposed to be like stable and good. Not. We have lots of things to ablate here, right? Got this version. Okay, right, this version. That's stable. So we have the original DQN stable at this point, yeah? Let's see if we can get the original architecture back in and still have it stable. Or if this screws it up somehow, right? Work basically off of this. So this will be, we uncomment these guys. Comment these guys like this. Val. Date. This. And encode observations. This. And we have to remove this synchronization thingy as well. Way less stable, right? I don't like the fact that there's a frickin' separate target network. Super jank. And this does something, but... What is the point of this thing again? Is this in the original DQN? Doesn't seem like it. It was introduced later. Okay. So, is there a way to get rid of it? Because this is kind of, not a good thing to have. Like, at all. Freaking double your network size. Have this super janky synchronization problem. I really, like, I'm fine if I need a separate head on the same network. But, like, this is a pretty immediate... Well, hang on. I mean, this is a big change. I kind of did this stupidly, didn't I? Yeah, hang on. I did this ablation really stupidly. Hang on. I kind of screwed this up massively, didn't I? Not go back that far. This. Two. This. Okay, so this is the separate network version, right? And I think that I don't even have these. Do I have these synced? Yeah, so let's not synchronize them. Let's see what happens. You don't synchronize them. Nothing trains. If I do like this instead. This works perfectly fine. Entropy hitting 0 sooner better? No, it is not. You generally don't want your entropy to collapse. Okay, so yeah, this seems to work, guys. Like, at least for this simple problem, not having a separate target network is like totally fine. And that's kind of actually important because we should be able to now use LSTM like this, and then self target self.q. This. We should be able to do this, I think. Consistent input size. Need this. Okay. Well, very slight hit to stability. But this is fine, right? So, having shared target, A-okay. Works with LSTM, works without LSTM. Exactly, right? This. Back to tiny network. Introduced by... Is that not the original DQN paper? Oh no, that's not the original DQN paper. What? Yeah. This works. At least now we know it's not like everything frickin' breaks. At least on this simple task, right? So we have things that we can play with now as a result of this, right? This target here happens if we do this. Super unstable. Does learn something, but super unstable. Okay. What is the motivation for adding off policy? PufferLib should be a guy that believes in problems. It can, given enough data, right? So the idea is that this should allow you to... my goal is to come up with an off-policy variant here that's basically the same exact algorithm as what I have now, except we don't have the off-policiness issue. So if we want to reuse some old data, we can do that without crashing the algorithm. That's it. So, what is wrong with this? Did I construct... I construct the target wrong. Is it just this? Well, there we... Well, a little unstable, but, Huh. Very unstable. Funny. I plugged this into an advantage estimate, right? And we can see that it's like... It's learning. That's about solves the task right there. Then it gets unstable, potentially. Okay, let me think about this, because maybe I did this weirdly. So the idea was to add some sort of advantage estimate in. We use for this target network. I'm resisting the urge to put this into Grok because I think it is just going to give me some bullshit. You want to have the maximum value or the action value. Try QA. What if I do like sub A? Sure. Yeah, you have the same thing of it being like quick but unstable. I will stick it into Grok real quick just to sanity check. I don't know why. I know this is a bad idea. I'm going to do it anyway. think that this is the same thing as I've done it. The only thing I don't know is if you use the Q function or the target function. I should probably just think about it a little bit, but I think that there's something else screwy either way. Oh, do I need to look in retrace? I thought retrace was rather different. Oh, you know what? You actually can't, right? Yeah, you can't do this because it's off policy, right? You actually do need retrace, which is probably going to be the exact same thing as I have, but with importance sampling, right? Is retrace in here? No. Mare. Okay, so this is what you would do here, right? They don't have, like... It's a super mathy paper without a ton of results. But if this simplifies to GAE, then I should actually just be able to... It's probably going to just be like GAE with important sampling, right? Yeah, so off policy. Oh, but you also have tree backup. Important sampling ratio, truncated at 1. Analysis of retrace. Yeah, I'll read. In fact, this is going to end up being almost exactly what I have already, because I actually already have incorporated, Puffer Advantage already has important sampling in it. So this is actually quite good, because this is going to be a bit of a pain, but this is at least like reasonably close to what we have, right? Like I already have an important sampling based advantage estimation kernel. I am going to have to modify it so that it makes sense. Okay, before I do this, here's a question, right? Should I expect to be able to have our current JE work with... I think I should be able to have our current advantage function work because the data is pretty much on policy, right? Because, like, I don't actually have a buffer sampling yet. So let me spend a little bit of time on fiddling with this to see if I can get it to be stable. Then we're going to do the retrace correction, and we'll see how much time I have after that. I'll be right back. Go check one other thing as well. There was supposed to be somebody out for the AC here by now, but I haven't heard a peep. Let's look at what does this use? This uses both the target and this uses Q target evaluated on the action, which is shared in my case, so it doesn't matter which one you use, but it would be QA that you would use, like the action condition one. And this would be Q sub A. Set the ratio to 1, which is fine if it's on policy. And this works, but it's unstable, right? Oh, wait, this just works. This QA target equals advantage. Huh. Okay, so then this works and is stable. Yeah. Well, okay, it can bounce a little bit. But isn't this supposed to be MB values plus advantage? Isn't that supposed to be this? I mean, evidently not, right? Yeah, let me see what the how we're supposed to actually construct the loss. Running will be there in about an hour. Oh, okay. Cool. So I didn't miss them. They're just late. All right. So back to this. Um. Right. We need to figure out. So right now I have this set to the advantage, but I think that you're supposed to set it to the return. And the return is a different quantity. It's this plus the value. Loss function. Q minus Q ret. B. Wait, reward. Okay, so this is recursive formulation, and it does have... It has this of the next state, right? So it's plus value. But what's V target? V target is the maximum. Is this already taken into account, perhaps? Why do you adopt weird terminology? You equate value-based, policy-based, off policy. Um, I mean, off policy is generally just you have a Q function so that the policy that you are optimizing is not the policy that's necessarily generating the data. And on policy, supposedly it is, but not really. Oh, look, all the terminology is wrong anyways. Literally all the terminology is wrong anyways. Hey, Kevin. I'm trying to figure out... I don't like the fact that this shifted one over, right? Doesn't our advantage already take this into account? The advantage is normally it's usually normalized as well, right? Okay, so let me try something. We do Do I not shift this somewhere? Okay. Hmm. Okay, so there is possibly an indexing screw up here. You do want this to be like MB values plus advantage, right? But then this doesn't work. All right, let's try something different here. I want to see, where's the advantage normalization? So advantage normalization is like essential for the on policy. See, where did it go? World model for RL. Yeah, that's a meme. That's not working. No way. Oh, here it is. Right, so we do it like this. What happens if we add just advantage normalization? This does solve the task, albeit quite a bit of instability. Does doing this make any sense in a Q-learning context, though? You're trying to RL on, like, hallucinated sims. It, like, makes even less sense than normal model-based RL does. At least there you're getting fresh data. Without this, no, you still have instability, right? Yeah, you still have wild instability. Which it gets, like, towards the end of training pretty good. But I think this is kind of okay. Oh, hang on. Yeah, this is the advantage function is going to be super messed up because it's actually your off policy immediately anyways because of the crazy epsilon greediness. All right. We have this in here as an option at least, and we'd like to have this at some point because it'll make the distributional RL thing actually work reasonably. Can we not try this? Hang on. We can try this without advantage estimation, can't we? If I just do like targets like this, and I just do target full target minus mean. It does actually optimize. So if you just norm targets, I'd say it's way less stable than not norming the targets. I have to think whether normalizing targets makes any sense. But you can technically do it. Alright? Okay, and then there is now... Do we go figure out retrace? Is that the main thing that we have to do? I mean, there kind of seem like there are several things. Simulated worlds. Yeah, but the simulated worlds suck. I think they're literally just gonna, like, exploit errors in the sim, basically. Not, like, the simulated worlds suck and they're super slow. They did get it to be coherent enough that it's not a total fever dream, but, like, it's nothing like an actual fix sim. Yeah, sim to real doesn't even remotely enter into this conversation. Like, it's a mess way before that. It's not just a sim to real gap. It's literally that you are creating a gap. Like, you're optimizing for a gap. Wait, what? Can you not just... Okay, so... Evidently, this is actually a thing. Supposedly. So let's put this in here. I don't like how jumpy this thing is, but it does optimize. Somewhat. I think we can actually try the HL Gauss thing with this now, right? Because this is no longer a mess, maybe? Oh, how are you? Switched Windows? No, it's just that I had this old, this desktop at this place already had Windows on it. I don't want to go through the effort of reinstalling it. As you can see, I'm working here SSH'd into a Linux box anyways, so. Okay, so this optimizes something. Not great, though. USL? Yeah, but like I'm on a native Linux environment here. I'm just SSH'd into a Linux box, so it doesn't make a difference. Yeah, so this doesn't work at all. HL Gauss, which is funny. Means I'm probably doing it wrong, right? Like, this is still the most stable version. Do we try to do retrace now? No, I don't. Something is still wrong. In my mind, I think something is still wrong here. What about this? So we do target. What did I do? Okay, so here is this version of it. And like, it doesn't really work. If I do this, not at all, right? Oh, what? Star. Okay, but hang on, like, this is not even supposed to work now, right? Because, yeah, this is not even supposed to work because of how off policy it is, right? So maybe we should not be worried about that. The HL Gauss not working is, I think, much sketchier in my mind, right? Like, say we have this target. So this works instantly. Maybe that's the thing we should do next. Distributional's supposed to work really well, and the fact that it doesn't is sketchy. This thing works. Do like this. Just super unstable. Like, the Q just blows up. Oh, hang on. I see it. I see it. I see it. And I was missing a detach up here as well, am I not? I'm missing a detach up top. Okay. So there are a lot of things wrong. Hang on. View size. Doesn't work at all. Lovely. That's things. Bugs. Okay, so there's this working, right? With the correct detached loss. Okay. Next one. Why does it not this one? Well, Q and the targets blow up. Like, instantly. What happens to Q and the targets when I don't do that? They still blow up. Yeah, they still blow up. Nowhere near as badly. Into 20. Okay. And this blows up dramatically. For some reason. Is this how it's supposed to be? Should be, it's just a quantization of both of these, isn't it? Hang on. Second. I gotta put a note on the door. Okay, so did I do this reasonably? I think this one is. They do have a Q function here. Target distribution also a categorical distribution. How do I apply this? That one sucks. Um, where is this thing? To represent Q as the expected value, categorical distribution. But what I want to figure out here, right, is I know how to do this when you have a single value function. A video showing current task complete about ARM, how I did mathematics and all. Look, thank you very much. I definitely will. I need to finish this off-pal stuff. Or at least, like, make a decent chunk of progress on this today. But that will be up on the agenda. I have, like, basic stuff working. But, like, all the additional tricks, I need to be very careful to do them correctly. Okay, so you have your Q function. TD cross entropy. How the hell is this a TD error? You have the probability. State action theta. It looks like to me. It looks like they've made two different distributions, right? Presumably these are the two different sets of weights. I'm trying to figure out if I did this correctly, because all I did right here is I just called it on both of these, and I don't know if this is actually how you construct this. Because, like, it's different in the on policy case where you just have one value function, whereas here you have the Q function and the target function. So I kind of just guessed that you do both of them in KL, but I don't know if that's right. I also don't know how this is supposed to work in Q-learning case when the Q function like tends to blow up a lot more. Well, I guess the value function does as well, doesn't it? But the thing is, you predict normalized advantages um, in the on policy case. And normalized advantages are a lot more sensible. Yeah, and then it just starts implementing stuff that I didn't ask it to implement because these models are fucking stupid, of course. Could have written like literally 2 lines. Prediction probs. Prediction logits. Yeah, these aren't logits though. This makes no bloody sense, right? Because the targets now. And then this is just KL, right? Categorical distribution. Okay, this is gross. Super frickin' expensive, I guess. But then you also have the separate target, right? Okay, so you only HL Gauss the target network. It's so stupid that you need this sort of a hack. This is why I've always hated off-policy learning. They do like a whole bunch of stupid mathematical hacks to make their crappy base algorithm work. Like, none of the off-policy methods get near the on-policy methods until you do all this bullshit. That seems screwy to me as well. Okay, well now I have to test a whole bunch of things, right? Noxious. Okay. I guess we just go try to implement it and see what we can do about this. I mean, there are a whole bunch of things I have to do even as prereqs, though, right? So, like, go back to this one. Oh, come on. What did I break? This one should definitely be stable, right? Why is this suddenly not stable? This was the stable one that always worked. Okay, whatever. There it goes. Hang on. One sec. Okay. HVAC being assessed. Does not make buzzing noises that drive me insane. First thing, target network has to be different, right? So we do encoder, we'll go to this. Target network. Try a couple different things. Q network first. So this should be the same as before. Right? Gonna act weird. Is this not the exact same thing as before? Could be, right? Standard deviation, maybe? I do. Literally same as before. Is it just different run to run or something ridiculous? Okay. You can get unlucky runs. Cool. Now we do separate target network. This still learn. Partially shared. And they're not synchronized. In fact, they cannot be synchronized once I make the modifications. And that makes it way worse, right? Okay, so how is it then that... How is it that supposed to have separate Q and target nets that you cannot sync? Distributional thing. So weird. And this is supposedly one of the main things. Suppose we can just try it, right? Really, man. Not, we don't need this, do we? So hang on, we don't need like this. Action actually gets to stay the same, thankfully. Actions do not match actions. And then the Q function. How do you sample from this? We do not want how the hell are these logits? They're not. Right? They're not. It's obnoxious. Sample this thing. Grab random actions for now. Then the idea here reshape the queue, right? Shape row. Something like this. Does this not work? Oh, okay, it's just the view that's wrong. Just we'll hard code everything for now, it's fine. Okay, so this is our QA. Just ignore all this stuff for now, right? This gives us our target. And right here. Okay, so now we have QA target and okay. Skip this reshape, I suppose. Skip. Oh. Okay. Target. $151. I guess it's 51, right? Okay, and now you get your thing here. And now I think you can just run kldiv, yeah? This is on QA. Yeah, and this doesn't learn anything. Lovely. Nothing at all. Proc code, we'll check the CNRL code, we'll check everything. Oh, well, of course it doesn't learn anything. I forgot the sampling step. Duh. Alright, let's see. How do they sample in C51? They have, yeah, they have the same thing here, okay? Get action. Okay, what's get action do? Probability mass function for action. Argmax of key values. So gross. Self atoms or whatever is. Okay, so you have to do the super gross thing to even sample action. Have your atoms. Then we have our sample. Okay, so you do softmax q dot view. One 51. Two values. Two. Actions not match action space. Okay. Do here. Oh, this should be. There we go. A little bit. Not going to exactly call this encouraging. QA gets to be a reasonable range at least. I think the value it's supposed to be 100, right? Ah, okay. It's like, at least it does something. No, at least it does something. Probably lots of implementation bugs to fix. Why is the target so weird? Oh, no, that makes sense, actually. Okay, so it's something. It's funny that the thing that's worked best so far is the original just Q-val formulation. Q function, DQN formulation. This is supposed to be like way better immediately, no? One second. 1 second, folks. Well, yeah, air is no longer going to be, AC is no longer going to be keeping me up at night with horrible rattling. Nice. We'll buy a couple things for it, but at least for the time being, no more crazy rattling. What time is it? 410. Yeah, another hour and a half ish. So I mean, what's going on with this, right? Like, is there Clean RL has like something that has dagger. Nothing else with distributional. It's just C51, right? Let's see if I can figure out from here. So, you get a Q network. It has some atoms, whatever. Wait, actually, is there no separate target? Wait, what? There's no target network? On? Oh, wait, no. It has a Q network, target network with the same num atoms thing. We have an HL Gauss implementation for off-pol. Great, it's in frickin' Jax. Can never write any frickin' code. Where? We're on control tasks as well, which is going to be different. Not like the PyTorch repos are any better half the time. As a repo, doesn't it? Oh yeah, this is Lucid Reigns. Yeah, but this is not on anything. This is just the loss, right? Yeah, this literally just has the loss. Okay, so the C51 agent is different, no? How would you apply this? On... Don't apply HL goes to Q functions outputs, only to scalar T target. Hmm. Where's the C51? Oh, it is just distributional. Cool. So this is the paper, the original distributional paper. And then this one, evidently they do this for... They do this for both the target nets. And then there's the stop progressing paper, right? Is this it? That's retrace. Stop progressing? Yes, it is. So we get classification with Gauss. We get okay. So 251. Get a pretty decent jump with HL Gauss here, right? Actually, MSE is. These are actually pretty close, and HL Gauss is the only one that does. Well, I suppose that directionally here, the MSE gets worse with more updates. Gauss is a lot more stable. Hmm. Network. Apply full distributional Bellman. Simplify this. Apply it only to the scalar target, not to the Q network outputs. Well, how the hell are you getting the scalar target then? Target network. Oh, I see. So, because here they're doing softmax times support, and then this is going to give you the mean Q, right? So we can actually do this with a shared network as well. Yeah, we can do this with a shared network. I see it. Do this with shared net. Okay, so target is self Q, right? Okay, so now in order to get the Q values argmax, fine, you get your Q values argmax the same. You don't use the target net at all, right? Yes. Don't use the target net at all here. Down to here, we're gonna want to take the couple of lines, right? Then we need to do this. Okay, and then Learn something. Makes sense, though, that we do it this way. This, according to this, right, it's take the target network, which is batch size, num atoms, whatever. This is the last dim is going to be num atoms. Do soft max. Then you do probs times atoms. Right, probs times atoms. And 3D actions are this. That's next. This is target. And you actually take target probs. Yeah, HL Gauss on the targets. And the loss is a KL divergence, isn't it? Am I stupid? Y true log 1. Oh wait, this is different. This is just negative log likelihood, right? Okay. This is actually Q loss equals target hunt predicted probs max 8 something like this. Still way off. P51, it was 51 buckets. They have this on purple. What they do, and negative 100 to 100. They do use 101 atoms, right? Match exactly. 10, right? Well, at least now we don't have to worry about parameters, right? One good thing to do as a sanity test, right? Let's just do qprobs softmax, like this, right? This can be qprobs. Okay, and then this one, we can actually do this one here. But this is qprobs. Let's see if like this parameterized version works with an MSE loss. Wait, what? Did I do something weird? Weird, didn't I? There's several layers to this frickin' thing. Here's QA. And can I not convert this? I can convert this into probs, can I? Oh. So the value of this is so you do like this, then you do like this, right? Then you do target val. You do this. And this is now target val. is MSC QA val, and then this is target val, like this, right? So now this should be discretized. Hang on. Target. Target needs a reshape on it. This. Perfect. So these are, whoops, target val. Do.max1.view. I'm just trying to get something that I can like work with starting point. This is turn type stuff. Max. Okay, so now we have target val. We have QA val. All right, so now we can get target. MATLAB, come on here. Oh, because you don't need this anymore. Need this dot max. Okay, so now you have your target. Okay, so you have your values, yeah? I should be able to define a Q loss, QA val, and frickin' target. Comment everything else. And there should have been a long-winded way of just reconstructing the original DQN loss. Because what I've done here is it's discretized, but then you end up recomputing, you end up computing a mean, and you just end up with the original DQN mostly. Slightly different dynamic. And indeed, this is not super stable, but like passable. It does actually solve the problem at point, like passable. At least at this stage, it's not completely broken, right? It's not like completely broken. You know, conceivably, we could make some edits and stabilize this. Okay. So now instead, how does this make any bloody sense, actually? Thing is, this has got to be Grok lying. Let me see if I can find it in here, how they do it. Because they have... Okay, this is get action, right? Listen to Grok. Wait, they actually... Next PMFs. Here they do... Oh, wait, because this is get actions. Hang on. What do they call get actions? Get actions. This returns you the PMF for this specific action. And you get it for target network. You assumably get it for, you get the old PMFs from the Q network. And you construct some distributional loss, right? So presumably I should just be able to use this loss now, no? Which is the softmax of the action. And I just have to construct this a little bit differently, right? 2A take softmax. Right, because you need to be able to take max, right? So you take your softmax first, and then you do times atom stuff sum. Okay, so these are your values, and then you do max IDX target val target IDX 1. We do target equals. Oh wait, hang on. So this gotta be QA vals QA This is just an index select, right? Oh yeah, so this is QA PMFs. Actually, we're done here. That's all you need. This PMF. You don't need it projected onto atoms at all. Okay, but for target you do, and the reason is that you need to be able to select from it. We do target PMFs softmax, and then we do the probs. They're not the probs, are vals. Okay, and then we do target val, target index, you take the max. Then target max F. And we probably want this to be unbatched. Complicated. Softmax. Okay. QA. Not. Let's not view this as a sequence, right? Target and QA are good. Now, target has to be QA PMF. Going to be QA 1. This get multiple. Hang on. How do you compute? PMF is going to get action. This already projected. No, it's literally just the softmax applied to Q values are returned. This is for sampling. For sampling, you have to do the Q values, right? Okay, but this is fine. So you get your target PMF, and this is actually target Q, right? Can be target Q again. Don't need all of them anymore. This is target Q. Max of 1. Let's see what this gets. Now we have target Q has gotten us the singular values here, but index, we need target max PMF, right? This is 32. Okay. Target index. Now this gives us a target max PMF. Max shape QA PMFs. Okay, cool. So now we have probability mass functions for the Q function and for the target. We have it for both. So there's a whole bunch of graph down here that we ignore for now. And oh yeah, how the hell do you do this? Weird, man. I got another almost an hour. All right, let me figure this out. Where's the... Okay, so you have right here rewards times atoms. Okay, so you actually... Right, there's this whole bunch of weird projection math. And this is where the HL Gauss comes in instead. Right? Yes, this is where HL Gauss is supposed to come in instead. This is supposed to be... Oh, right, because you know what it is? It's the first step of HL Gauss, right? So you have... Where's the stupid? Here's your support. Take your input. Used. It needs to be applied to... I wish I had like an actually good implementation of this to reference. I could try Lucid Reigns and like just hope it's good. I implements literally everything. Okay, so you can... This is what you would do, right? So it's transform from logits, and then it calls transform from probs. Gonna do probs times centers. That's it. Wait. Forward. Log prob. Transform from logits. Super confusing the way the stuff is written. Do I trust Grok to not screw up the frickin' math if I just want mathematical description of this thing? Really don't is the problem. Tried to write a thing here, didn't it? Targets. Scalar TD targets. This seems wrong to me that you have scalar TD targets. Right? There was another thing in here. Not this one. Where is it? D51, you apply the full distributional Bellman operator. You compute the scalar... Okay, so actually this is correct. That's so bizarre, though. Compute the scalar TD targets, and then you transform into the target distribution using HL Gauss. That's bizarre, right? You compute a full distribution, and then you turn it back into a scalar, and then you reproject it into a different target distribution. So weird. Just predict them. Oh, you know why you don't predict the scalar? I know why. It's because you can't train that network, right? So this makes the network match the Q network, so you can actually train. Okay, so I actually see why you would have to do it this way. The chat broken. Nobody said anything in a minute here. I mean, I guess I am kind of just doing crazy algorithm dev at this point. Nope, it's not. There you go. Perfectly timed A1. It's like one hot encoding of a label into a cross entry. I don't think it is. It's more like, let's say that you had a full probability distribution as your target, okay? And then you turn it into a one hot, and then you turn it back into a distribution. That's what it's like. Which is crazy. But this does make me think that I have it done correctly. I guess the question's like, why the heck does this do work? Why does this do better than C51 that actually keeps the full distribution? I don't know. Does this even do anything at scale, or is the entire foundation of off-pol RL just built on a bunch of dumb hacks, like weren't fully validated? Who knows? Trying to understand. That makes two of us. What the heck did they do? They just wrote a ton of math for something that always ends up being very, very silly. But let me see. So I have... Wait, I can't actually compute this now, though, right? Because... So this is... I have my target Q, right? So here, this is target Q. And then this is... and equals. Okay, so if I do this, right, I can just do Q, then this is going to be target, and I can just compute this loss, and then basically this should give me, like, the mean squared error loss version of this. Hang on. So this is not the full power of the algorithm at this point, right? This is supposed to just be project everything, and then you kind of project it back, so it's the same bloody thing. Okay, this is your Q. Okay, so now... Table. Okay, so this is like reasonably decent. As it flops a bunch. Of course, and it like flops a bunch at the end and totally screws up. But that actually did solve the task. Okay, so what I did here is I did all of the probabilistic, I did all the projections. Well, I did not the HL Gauss projection. I computed the PMF and then I projected it back into Q values and then just did MSE. Okay? And now next, what we do is the full HL Gauss. For this, we go here. PMFs. MFs. 2A U. 512, 64, 100, and we do target equals HL Gauss target U 1 UHL Gauss on our target equals put it back into shape that we understand. This. Okay. Then target. The Q probs should have just been softmax. Maps should be something like this. Watch chart. Plug this in real quick. What is an HL Gauss? It's a distributional loss function, or it's a transformation that's used to create a distributional loss function. Rather, I guess is the simplest way of putting it. The really simple way of putting it is instead of estimating values or Q functions like as continuous numbers, you bucket them a bunch and then you write loss function over the bucketed values instead. And this is supposed to do something, but we're not exactly fully seeing it yet. Heavy lift Gauss? Oh, I prefer that. Yeah, the heavy lifting function. Good. Certainly feels like heavy lifting trying to frickin' get it to work. It's bullshit. Oh, I am realizing that I did not shift them by 1. this at least. Really doesn't work super well, huh? Yeah, I think that's something different. I think that's something different. It's this. The heck does it even stand for? I don't actually know what it stands for. It's from this paper, though. Neural nets are better at class. Try again with... I don't know what mids is. Yeah, I don't know what mids is. Or OMSA. I don't know what either of those programs are. I've tried so many different variations on this, and it doesn't seem to work better. Online math. What? I didn't know about that. Particularly for online programs, I don't know about that at all. It's hard for me to say, because, like, I mean, I'm not the type of person who, like, will look at credentials and hire anybody based on that, because I know that like, the credentials never tell the full story. What am I doing wrong here? We go to unshared. Let's go to unshared just to be absolutely sure. Right? Because that technically could be a thing. That would suck if that were the problem. But we will see. Go to unshared here, right? Yeah, that's something totally different. Yellow is something totally different. Just an activation function. Has nothing to do with what I'm working on. I'm using it, but it has nothing to do with what I'm working on. Okay, there's your target net. So here's your target. Got the data copy in. Now let's do... Already have this bit. I'd say coursework really shouldn't be that hard, but like any of the courses are basically designed to screw with you rather than to teach you things. Ah, okay, hang on. Well, it's super jumpy, but like we're actually seeing something there, right? Now with it unshared. I suppose the number of updates needs to be tuned and such. There's a huge amount of variability in this. Total mini batch. You know how people can make like programs that are just dramatically more complicated than they need to be for no apparent reason? You can do the same thing with math, it turns out. The exact same thing with math. Okay, there's a consistent update schedule. Okay, that's way better, right? It's like, I think probably whenever the target gets hit, it like crushes it for a second. But this is chill. That actually made a big difference. Okay, so we actually kind of have this working then, right? That's HL Gauss implemented. Code's a mess, but we do have distributional RL working. Plus, just I like C because I like simple things. I really hate puzzles, you know? I hate, like, clever things. I like simple things that work. I like it when I can take very hard problems. They're, like, super obnoxious, and the solutions are almost not even worth their weight. And I like to just cut them all out and do simple things that work. That's what I like. I'd rather be useful than clever. Well, that's the thing that everyone has to decide for them. Rather feel clever or would you rather be useful? They're often directly at odds. Because in fact, the least clever solution, typically, among all of them, the best. The easiest to frickin' follow and extend. I will be very, very happy if at the end of the day, I run all the experiments, I test all these methods, and I find that most of the complicated things are a waste of time. I just have the simple algorithm that, like, is super fast, very easy, and just solves all the problems. RL becomes a mature field, a high performance implementation of that with extensive validation. Pretty much any problem you can want, it'll solve better than about any of the other existing algorithms. No real edge cases. Works. That is the goal. That is what I would like to see happen. Well, this does give us our distributional RL. We had to do unshared networks to make it work, but we did do it. So I guess tomorrow would be well, tomorrow I have other stuff, but the next big chunk on this will be retrace. Right? And then once we have this into retrace, pretty much this will be at the point where it has enough of the bells and whistles that, like, a clean version of this should already be enough. Right? Like that I would expect um HL Gauss version of this with retrace to be competitive with our existing method if it's any good. Not any good, different story. We could technically also mess with the replay buffer stuff. We'll get to that later. Two different. Oh, geez. It's a good start. It's a good starting point. Anything else I can do? Really? Kind of the main thing for now is set up. Do I need to do retrace before anything else? Probably do. I probably do need retrace, right? Like, otherwise you have no advantage function, basically. You're doing, like, one-step bootstrap. Yeah, retrace will be next session. Yeah, I mean, the best people around here are just the people who stuck around and learn stuff properly. I haven't even asked anybody that I've brought on for contracts about their credentials. I have people emailing me resumes all the time, and it's like, what am I supposed to do with that? Yeah. Okay. So I gotta go get ready for dinner. I'm meeting somebody for dinner today. Tomorrow as well. Tomorrow I have most of the day I have I've got a meeting to go to and I gotta set stuff up for that. But I will be working on either tomorrow or Friday, most likely. We're gonna figure out retrace. I'm gonna do a little bit of reading offline on retrace to see what I can figure out. Very fancy method. I bet you that it boils down to like not that much. This paper here. Hack and mod games. Fun. That's fine. Generally, people should at least at some point go through an intro course so you know like what a hash map is, but also basics of how your computer works, what an operating system does, at least a little bit. But other than that, yeah. Anyways, thank you, folks. I will be back probably tomorrow. Thank you for tuning in. It's gonna be a few days of this, I think, to like get an off policy thing in. But in my mind, I really want to give off policy a proper try. Like, I want to be very, very confident if off policy stuff doesn't work, that it's not because I've screwed it up, and I want a clear cut reason as to why it doesn't work. So we're going to push the experiments quite far there. So thank you, folks. Back tomorrow.